In this lecture, we are going to do a few more tasks in Colab. Specifically, we're going to look at some ways to upload your own dataset to Colab. Let's say, for example, your client or employer gives you a CSV file, or you downloaded a CSV from Kaggle. How can we then make this file accessible from our Colab notebook? In this lecture, we are going to discuss a few different ways of doing this. The first method we're going to look at is just to use the classic Linux command wget. As mentioned previously, you can run command line commands by preceding the command with the bang symbol or exclamation mark. So let's go ahead and download the arrhythmia dataset. Now, we want to check where the data went, so let's use bang ls to see if the data is in our current directory. Okay, it looks like it is. Now let's use the head command to see the first few lines of the data file, and also to check whether or not the file has a header row. Okay, so it looks like it does not have a header row. Next, let's try to load in the data using pandas. We're going to pass in header equals none, since we know that the data does not have a header. Next, since the data has many columns, we're just going to take the first few. We're also going to rename the columns because they're currently just integer values. As usual, since this data is from the UCI machine learning repository, you can just check the documentation if you want to know more about the data, like what each column is. So let's run this. Next, let's create a histogram of these data columns. Since Notebook by default makes the plot pretty small, we're going to import matplotlib and change the figure size. Once we've done that, we can call df.hist to create histograms for each column. Note that I've added a semicolon to the end of df.hist, because if you don't, then Notebook will print out the last returned value like it usually does, which we don't want right now. Okay, so here are some nice histograms for you to look at. Next, let's create a common plot for data analysis, the scatter matrix. This does a scatter plot between each feature and every other feature. Along the diagonal, it just plots a histogram of each feature, which we've already seen. All right, so pretty standard so far. Next, let's look at the second method of loading in data, which also applies when you have a URL. This is to use TensorFlow directly, specifically the keras getFile function. Now you might be thinking, why would we use TensorFlow if this course is about PyTorch? That's a great question, and I would understand if you were hesitant. However, it's important to realize that these are all just Python libraries. You're not restricted to using only one or the other. That would be silly. As an example, there are several libraries for making HTTP requests. One is called requests, another is called URLlib. I don't think anyone would hesitate to use both in their Python code. If you need more convincing, it's actually common, even if you're working in PyTorch, to make use of the text preprocessing functionality that comes with keras. So in fact, data scientists and machine learning engineers have already been doing this for years. Don't think just because I'm using PyTorch, I'm not allowed to use the utilities from any other deep learning library. Let's start by assigning the URL to a variable called URL. We're going to be using the AutoMPG dataset, although it doesn't really matter what you use for this example as long as you can access it directly via URL. Let's run this. Next, we're going to make sure we have TensorFlow 2.0 installed. So we're going to run pip install TensorFlow and then print out the version to make sure that we have the correct one. Note that when I first created this lecture, TensorFlow 2 was not yet released. Today, you can just do import TensorFlow as TF, and it'll automatically load the latest release, which should be 2.0 or higher. In addition, remember that this uses the Keras API, so an equivalent alternative to this would be to just use Keras itself. Whenever you see tf.keras, you can replace that with just Keras. So tf.keras.getFile becomes keras.getFile, presuming you imported Keras earlier. Although remember that Keras installations still require a backend, so ultimately you would probably already have TensorFlow installed. Next, we're going to call the Keras getFile function. The first argument is the file path we want to save to, and the second argument is the file source. So let's run this. Note that it's possible to save the file to a different directory, but we'll be saving it to Keras's default folder. So you can see from the printout that the file ends up in /root/.keras/datasets. Next, let's call the head command so that we can see the first few lines of the file. As you can see, it's not exactly a CSV. Instead, each column is separated by whitespace, and there is no header row. So in order to load this data, we can still use the pandas read CSV function, but we have to pass in 2 extra arguments. The first argument is to say that there's no header row, so header equals none. And the second extra argument is to tell pandas that the delimiter is whitespace. So we set delim whitespace equal to true. Next we call df.head just to make sure everything works as expected. So as you can see, the result appears to be in the right format, and from here you can process this data using Python code as you normally would. The third method we're going to look at, in order to add your own files to Colab, is to upload the file directly. In order to do this, we have to run a special Colab function. So we say from google.colab import files. Then we call files.upload. So let's run this. So you see that this creates an upload button, which we can click and then choose a file from the local file system. So I'm going to choose daily minimum temperatures. Okay, and if we print out the returned value, you can see that it's a dictionary where the file name is the key and the value is the file contents. Now if we use the command bang ls, we can see that the file has been uploaded to the working directory. Next, let's read in the file using pandas to make sure we get what we expect. Now this file has some garbage lines near the end, so I've accounted for that by setting the argument error bad lines equal to false. This ignores errors but prints them out as they are encountered. As you can see, the file is loaded in successfully. To follow up this example, we're going to look at a variation on what we just did. You recall that when you're writing code in Python, sometimes it's useful to split your code amongst several files. This helps to organize your code and keep similar things all in one place while keeping different things separate. As a simple example, sometimes we'll learn about multiple algorithms in one course, but we'll test all those algorithms on the same dataset. So there's no point in rewriting the code to load in the dataset multiple different times. Instead, we can write the data loading code once and then import it from each file. Now, you might wonder, since we're working in Colab, how can you import a function from a Python script if that Python script is on your local hard drive? Luckily, we can take the same approach we already have been to upload that file to Google Colab. So here I'm going to call files.upload again, and this time I'm uploading the Python script fakeutil.py. So fakeutil.py contains only one function called myUsefulFunction, and all it does is print out hello world. So once you've uploaded the file, you can see that we can import it just like we would if we were working locally. So I can say from fakeutil, import myUsefulFunction. Then when I call myUsefulFunction, you can see that hello world is printed out just like we expect. And by the way, you might be wondering, as I did, what the path of the current directory actually is. To determine this, you can just run the usual Linux command pwd, and that prints out /content. So /content is our current working directory. The last thing I want to cover is something you're probably all wondering. Google Drive is for storing files, so is it possible to access files on your Google Drive? And of course the answer is yes. So in order to do this, we have to import Drive from Google Colab. Then we have to mount the drive by calling drive.mount and specifying the path /content/G drive. So this is going to give you an authorization code. So you go to the URL in your browser. Okay, it asks you to sign in. Asks you to accept some terms. Okay, and then it gives you a code. So you copy this code and you put it back into this box. You hit enter. Okay, so that works. So after we've done this, we can call ls again to check what's now in the current directory. We can see that there's now an extra thing here, G drive. So let's ls G drive and see what that gives us. All right, so it looks like we now have a thing called Google Drive. Let's again ls this. And remember that you have to add quotes if your path contains white space. And now we can see a bunch of files that are in my Google Drive, which is essentially a bunch of VIP content for the VIP versions of my courses.